Hi, this question is one of the challenging questions for the IB students. But today I will tell you very easy technique, not only the one technique but the two methods. With the help of that, you will not be only able to understand how we apply the Newton's second law, but also you can next time tackle it very well. Okay. So we see that there are two blocks. The one is stacked over the other block. The one block which have a larger mass, the other block which have a smaller mass. And in this question, they say that the surface of the two blocks is not smooth. They are that is rough. Okay, but the surface of the table is frictionless, which means that there will be no force of friction from the table on the bigger block. Understand? But let's say if I try to pull this block to the right side with some force, what will happen to this block which is placed over that block due to inertia? Just imagine, just visualize that due to inertia, this block wants to at rest. Okay, that is a property of inertia. So when I am trying to pull the larger block towards the right, I'm trying to accelerate it. The upper block will try to maintain its state of motion due to inertia. That's why it is a chance that it could slide in this direction. Understand? So when it will be trying to slide in that direction, which force will keep it at rest relative to the upper lower block? That is, dear students, this force, that is a force of friction applied by the lower block on the upper block. Understand? So in this question, you have to calculate the maximum force so that the both blocks move together. Together means they move as a one system, which means that the upper block does not accelerate relative to the lower block. I hope you understand that. So we will draw the free body diagram and easily apply Newton's second law. Let's say this is a small block M, and the how many forces are exerted on it. So the one force that is applied upward is actually the normal force applied by the lower block on the upper block, which is due to Newton's third law of motion, right? The reason is that the upper block is pressing down the lower block, and as a result, the lower block, which is the bigger block M, is applying the same amount of force of contact on the upper block. So it is pushing the upper block up, and the lower upper block is pushing the lower block down. Both forces are equal in magnitude and in opposite direction according to Newton's third law. But when we talk about the free body diagram of this smaller block, so you see that there's another force that is countering this normal force, and that is the force of gravity. And obviously, the third force that I had already mentioned is the frictional force right now. Okay, so this is obviously a resultant force. Dear students, why? Because there is a no fourth force that is countering this frictional force. So since this is a static force of friction, because the upper block is not relatively moving relative to the lower block, that's why we will use the mu s and the normal force. So mu s, normal force is equals to the weight, so mg. Let's put the values. We can take the value of g 10. Okay, dear students, this is a 12 Newton. Now understand conceptually, this 12 Newton is a maximum static force applied by the lower block on the upper block. It cannot be more than 12. Okay. Now in our question, we want to find the maximum force. So I'm going to explain you quickly the two methods. Since you know that the both blocks have same acceleration, right, as it is mentioned in the question, so A must be equals to the F, that is the maximum applied force divided by the total mass of the system, that is M plus big M, right? Why I'm saying just this is a big the big F reason is that because all the other forces than this F are balancing each other inside the system. I quickly explain you, the downward force and upward force are pair of each other. Frictional force applied by the lower block on upper block, which is I have already drawn here, its pair of force is the same force applied by the upper block on the lower block in this direction. But that is also balancing each other. So at the end, there is only one force that is left. That's why I have written here this one. Okay, so we want to find out the maximum force. You can adjust this thing on the other side. All right, we can find out acceleration from this equation, dear students, which is equals to small ma. All right, okay, because this was a resultant force. So you can find the acceleration from here, 12 over mass, that is 2. So its answer is 6 meter per second square. So we can put the value here and that will be our answer. So 6 into 2 plus 4. So that is, dear students, 36 Newton is our answer. Now the second method is, you see that this is a lower block, and I'm just going to show you those forces which are in the direction of acceleration, which are on x-axis. So the one force is obviously applied by your mechanical force, that is F, okay, and the other force, dear student, is the force applied by the frictional force, which is applied by the lower block on the upper block. All right, which is already we had calculated its value 12 Newton, and there's a no any other force on x-axis other than these two forces, okay, where the surface is already frictionless, this surface. Now, so if we apply the Newton's second law, which says that net force is equals to ma, so what is a net force? F minus 12 is a net force, is equals to the big ma. So F is equals to 12, if you add 12 on both sides, plus the larger mass is 4 kg and acceleration is 6. So we get the same answer, 36 newtons. So that's why this is the right answer is option A.